Well, hello guys. Good morning, and I hope you are going to find this video helpful to you as you are getting going on this week. We are in Unit 2.1 for geometry, and you'll notice that I wrote on here my instructions for the week that I'd like you, after watching this video, to complete page 86. I would like you to do each of those problems. There are actually only 7 problems on that page, so 86 all, and then page 88, I want you to work on the evens. Okay, so during this week we're tackling kind of a variety of different ideas. One of those ideas is called the triangle inequality theorem, which basically states that the sum of any two sides of a triangle have to be greater than the measure of the third side. So we're going to be doing some investigations with that in class, or maybe you will actually have already done that by the time you get to this, watching this video. Okay, and so really what happens is you have a situation where you can't have two sides, for example, like a side length of 6 and, for example, a side length of 2, let's say centimeters. We'll just call these centimeters. It's not really to scale. And then a third side that is maybe 10 centimeters. Okay. However you try and put these together, it's not really going to work out. You can imagine trying to get this 6 centimeter piece to stretch all the way across here and to somehow touch that 2 centimeter piece. And so you have 2 and you have 6, and you have this gap in between that is created because these lengths are just not long enough to actually form a triangle. Okay, so with any given two sides, that's what each of these mean, that if you pick any two sides, it's going to have to be greater than that third side every time. Okay, so this is basically saying just that, this little diagram. Okay, so let's look at how this might come to you in terms of a question. We'll leave the triangle inequality theorem right there so you can see it. So this might be a type of question that you would be asked. Which set of numbers may represent the lengths of the sides of a triangle? Okay, so you have to make sure that any two sides that you pick, any two sides, has to be greater than, not equal to, it has to be greater than to create that actual space in your triangle. If they're equal, they just kind of, the sides kind of fall onto that third side. So any two sides have to be greater than the third side. So we'll kind of test that here. We have 6 plus 6 is 12. That's greater than 7. Your 7 plus 6 is 12. That's greater than 7. So this 6, 6, and 7, that works to represent lengths of sides. Okay. Let's look at this one right here. 2 plus 5. 2 plus 5 has to be greater than 9. Well, that's not true because 7 is not greater than 9. So that's going to be a no for that one, right? Here's another one. These are kind of some interesting situations. If you have this situation where 7 plus 1, you're adding these two sides, and it's actually equal to but not greater than the third side, what ends up happening is you have 7, you have 1, and then you have 8, which leaves you no gap, right? It leaves you no triangle if that happens. So they cannot be equal. It has to be a little bit greater. So this is not going to work. And then the same thing happens here with the 4 and the 2, because we know that 4 plus 2 is not greater than 6. It's actually equal to 6. So this one doesn't work. That one doesn't work. This one didn't work. The only one that worked was D. Okay. Now, here's an interesting question. I really like this question. This forces us to kind of do a little bit of an analysis of what the possibilities might be. Okay, if two sides of a triangle are 1 and 3, the third side may be dot, 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 right? So we're picking from one of these. And that range of values for the third side, okay, this is how you find the range. You're going to have to look for numbers that are between adding 1 plus 3, okay, that's 4, and subtracting 1 and 3, okay, which is 2. So it can't actually be 4 and it can't actually be 2. Otherwise we get this situation where, right, you don't have a triangle, you just have sides laying on top of kind of covering one another. So it has to be between, okay? And betweenness does not include 4 and 2. It only includes numbers that are right here in between 4 and 2. So as we look at our choices, all right, for the possibilities, it looks like a choice of 3 would be our only possibility with that. Okay, so to find our range, remember you want to add the 2 sides and subtract the 2 sides to find that high number and low number that your third side could actually be between. Okay, so that will help get you guys going with the triangle sum. It's awesome. Okay, we're going to push forward. A little pause in the action, and we are going to classify some triangles. So classifying triangles happens by their angles and their sides. So I'm going to write for you the choices that you can classify for angles. So you want to have these written down somewhere. So for angles, our choices of words or terms to help describe a triangle are, it could be acute, it could be a right triangle, it could be obtuse. Okay, we also might say equiangular, and that little prefix means equal. So equiangular would be another way to describe an equilateral triangle. All right, and then when we classify by sides, here we go, we're going to classify by sides next. Okay, the choices for words you can use to classify by sides are, it could be a scalene triangle, and scalene means that no sides are equal. It could be an isosceles triangle, and that means that 2 sides are equal. We'll put no sides equal in parentheses here, and 2 sides equal here. It could be equilateral. Again, that equal prefix right there, equilateral. Lateral means sides. And that would be all 3 sides are equal. Okay? So when we are classifying, when you are working on classifying by angles and sides, make sure you pick 2 words, right? You're going to pick 2 words to classify, and one of those words is taken from the angles and what's true about the angles, and one is taken from what is true about the sides. Okay. Whew, we're making it through this. And then just as a kind of a side note, and I'm just gonna see if I can't move, I don't think I can move this down. That's okay. Just as a side note, because this is kind of a straightforward idea, but you really need to kind of actually see an example of it before it makes sense. Ordering the length and angles of triangles from the smallest to the largest, and that means from the smallest to the largest sides, or the smallest or the largest angles. And you can tell a lot from a triangle by knowing the side lengths or the angle measures. So let me give you a quick example, and then this video will be done. All right, so let's draw a triangle here. And I'm going to draw a acute scalene triangle, and let's say our sides are 8, this side is 9, and this side is 5. Okay, so I can order my sides from largest to smallest. Let's call it triangle A, B, and C. And so I know if I'm going from smallest to largest or largest to smallest, in this case, let's go smallest to largest. My smallest side is AC. That's pretty easy because it's 5. And then my middle side is CB. So you would name it by the actual segment. All right, that's how you would name it. And then my third side is, and largest side is AB. Okay, now I might not know the measure of my angles, but guess what? The largest angle is always across from the largest side. And the smallest angle is always across from the smallest side. So if I wanted to, again, name the angles from smallest to largest, my smallest angle is going to be directly across from my smallest side, right there. So angle B would be the smallest. And then here's my side that is the medium side. So I'm going to shoot across. Angle A would be the medium angle. And here's my largest side. My largest side is 9. Again, I'm going to shoot across to this angle that's across from it, making my biggest angle the measure of angle C. And I don't know the actual measurements of the angle, but that's okay. I'm just putting them in order from smallest to largest. And that is how you order triangles. All right, guys. Hope this helps this week. Have an awesome week. Make sure you're getting everything done, and I will see you in class. Take care.